We're very excited to have Heather Clark join us from Rocky Mountain Institute. And before we get into her presentation, I think we're going to hand it over to Jade, Lou, and Bev Craig from Mass Clean Energy Center to give a brief overview of a couple upcoming grants, the Act for All grant and the Empower grant, that are great opportunities for affordable housing partners, and with deadlines coming up this summer. So I'm going to turn it over to Jade first, I believe, and then maybe to Bev.
Awesome. Is it okay if I share my screen?
Of course. We'll have Dawn give you host privileges. And
yes, you need to give me 1 second there, Jade. I just got to make you a co-host.
And maybe for Bev, do you need them too?
Nope.
Okay.
And I guess while we're waiting for the screen sharing, why didn't I talk right before we started this call? Everyone was talking about, there's been a lot of news articles about how hot it's been out west, and especially about tree cover in urban areas and how urban heat islands can be really a challenge for those in disadvantaged communities. And a lot of that can be because there's not as much green space and tree cover. So I just, in response to that discussion, I was saying, well, that's like the perfect kind of thing that a community development corporation could apply to our Empower program, which is open right now for a planning grant up to $20,000 to investigate that and encouraging energy efficiency, or maybe community solar in their area. But like, think big. That definitely is related to buildings and heat and how much cooling people need, and resilience. So we would be very open to concepts like that. The one other quick announcement, just to plant seeds with all of you, is that in the next year, there's going to be a lot of workforce development money, especially for community members who live in environmental justice communities, coming from our agency, from City of Boston, a bunch of places. I wouldn't be surprised if a lot of recovery money or infrastructure money, if it comes through, will have a flavor around that. So especially if your organization does a lot of work around workforce development and trying to retrain people whose jobs might have been gone, or people who have not typically been able to get into higher paying jobs, please think or reach out to me, first of all, if you're interested in this. But we need groups to pull together great applications. So thinking about what support services would be needed for your community members to get into a training program, what training program would be great, and then what kind of like apprenticeship programs and job pairing would be necessary. So you don't need to have expertise here. I can see like a coalition of people, but we need people to knit together those ideas. And I'd be glad to talk you through where we see job growth, especially in green jobs, being really active in the next 10 years. And I'll head it over to Jade now.
Perfect. We switched the order, but that made more sense. Okay, great. I will just share one slide on our Act for All grant opportunity. So this is a grant we're offering under our clean transportation programming. And it's sort of part 2 of our pilot and demo grant program we called Act Now. So this one focuses a lot more on equitable outcomes. So the way we're thinking about it is increasing access to clean transportation technologies and decreasing burden for priority groups. This is just a little bit more on what we're offering in the program. So we're looking to fund projects between these 2 amounts. Applications are due in September.
One thing I don't see your screen.
Yes, we are not seeing the screen.
Sorry. Thank you for interrupting me.
Sure, I'm so curious.
Okay.
It's sometimes hard to tell.
I didn't hit share. Okay, well, great. Reiterating the things that I just spoke about. But yeah, I was just walking through these bullets. So one thing I do want to draw everyone's attention to here is that we're offering nonprofits, community-based organizations, etc., basically 7.5K to apply. So what that looks like is just submitting a letter of intent, which I can sort of walk you through on our webpage, with like your project idea, who you might be working with, etc. And that'll be a 1.5K payment up front, and then the rest when you submit your application. So we're really doing that because we're trying to achieve these equitable goals, and we know it's hard for small organizations, especially organizations that might not have engaged in these topics before to really get started and be able to put together a project. Other things that we're offering in terms of application support, we're putting on a webinar actually right now, poor timing, but it will be recorded and we will send it out. And I will also have to drop early for that. So sorry about that. We're also doing office hours, and we are convening stakeholders on Slack. And so we're hoping that that is a place where folks can just be like, hey, I'm interested in applying. This is a topic area that might be interesting to me. And people can begin to form project teams. And then this is just a little bit about our topic areas that you can read more about on the webpage and in the solicitation itself. Again, I'm very happy to answer any questions. People on my team are as well. And I do just want to, I will be dropping a lot of links, but I do just want to show folks the web page, and then particularly the parts on planning grants. Essentially all one must do is fill out a letter that looks like, oh, I wonder if this is not going to share. Can you all see that?
Mm-hmm.
Okay, great. Yeah, so we're just looking for folks to fill this out and just say, hey, I'm planning on applying, and that way you would be eligible for the planning grant.
Jade, this is Don. Can you also put your email address in the chat so people can contact you if they have questions?
Definitely, I will do that.
And I will say, I know a lot of you are talking to E for the Future to think about a similar model to what they're doing with Nuestra right now, to have an EV that can be shared by community car, so basically a zip car concept, but highly subsidized. That is fantastic, but you don't have to do that. You can do other things. Like I would say, some of you who are particularly worried about disproportionate pollution from vehicles in your community, you might want to think about applying for something that would help you. So we're going to have some fleet advisory services that will help target fleets to go electric vehicles. So say like FedEx has a depot right around the corner from your affordable housing or a school in your neighborhood.
Mm-hmm.
You can imagine putting together with that 7,500, like how do you target them? And then we can follow up with fleet advisory services to that group, right? Or maybe it's like a smaller business like flower delivery and they have a fleet of 10 vehicles, but you don't have to just do EV rideshare. It can be other things too.
Yes, yeah, and to that point, it's a little bit confusing because one of our topic areas is the sort of urban delivery area in Act for All, and we're also separately running a fleet advisory services program where we're basically hiring a consultant to do electrification services for different fleets, and we are looking for, as Bev was mentioning, we're looking for folks to tell us like this is a good fleet that would be eligible. So regardless of which program, like that technicality, if there are fleets in the area that you think would be a good candidate for electrification, reach out to us and we can take it from there. There are basically takeaways that there are multiple opportunities for that under our programming. So I will stop sharing there and just put my email in the chat, and then a link to our webpage as well as our Slack group. And thanks everyone for your time. I really appreciate it.
Awesome. Thank you so much, Jade and Bev. We really appreciate it. And yep, we'll make sure we include your emails for folks to reach out if they have any questions. Good. Okay. Well, without further ado, I want to introduce Heather Clark from Rocky Mountain Institute. We're so excited to have Heather with us today. Heather's going to talk about her latest project, but Heather has many accomplishments. One among them is the first large-scale deep energy retrofit in the US, right in downtown Boston at Castle Square. So a wealth of knowledge. We're very excited. And so with that, I will turn it over to Heather to share more about this fantastic project. Thank you, Heather. I wonder, did everyone freeze? Oh no, did Heather?
No, I'm here. Heather, I don't think we can hear you. You might be on mute.
I think she froze.
Yeah.
She froze. We'll wait one sec. We'll see if we can get her back in.
She sounds like she's going to try to log back in.
You'll log. Oh, there, we can see you, Heather.
All right, was that, okay, so do you want me to get started?
Yeah, that'd be great. We can't see the screen yet. If you need me to share instead, let me know.
Yeah,
Oh,
my
okay.
internet here should be great, so I'm kind of surprised, but okay, let's give this a shot. All right.
Good.
Thank you all for having me. So I'm going to be talking about Moran Square today, which is in Fitchburg, right? Downtown Fitchburg. It's we believe one of the first, if not the first, federal historic tax credit projects that's also achieving passive house. But layered on top of that is another goal, which is to use low carbon materials. Before I go any further, I just want to share our team who worked on this project. Reese Larkin, development, John Rudzinski is the developer on the project. TAT is the architect. My firm, Biome Studio, which now I am with Rocky Mountain Institute. So this project is under construction right now. I got the project through closing, which was in May, the end of May. And then I transitioned over to Rocky Mountain Institute. And at the end, I can talk a little bit about what I'm doing there. Peterson Engineering is the MEP. Building Science Corporation provided huge amounts of help on various things. New Frameworks is the low carbon materials consultant, and Advanced Building Analysis is the PHIUS rater. I should mention too, Peterson Engineering was the passive house consultant, and then finally Keith Construction. So with climate change, as we're considering how to tackle it, and as you all know, I used to many years ago in presentations talk about how bad climate change was going to be, and there are a lot of, I think, skeptics in the audience. We don't have that now. I think we're all really coming to grips with this is a terrible thing for humanity. We have to deal with it. We have to deal with it now, and all of us have an opportunity to make a contribution. In terms of global emissions for greenhouse gas emissions, buildings seems like about the largest sector in terms of contributing to climate change. Operations are about 28% of greenhouse gas emissions, but materials in construction are another 11%. So we have to not just think about how to really reduce the energy load of our buildings, but how to build them differently. At Moran Square, we really focused on that pie chart, and that is how we use that pie chart to really define our goals. So the first thing that we're doing in terms of decarbonizing Moran Square, and I'm going to take a step back to, a number of years ago, and many of us still use the term green building, and I feel like that term just didn't fully get how important our mission was. More recently, many of us are starting to use this term decarbonize, which means that we've got to get the fossil fuels out of our buildings. We've got to get our energy load down. We have to get near zero energy and zero carbon on our buildings. So let's start to think about decarbonizing. We're on a mission to do that. So at Moran Square, our three goals. One is that we're leveraging the embodied carbon of the existing buildings. People put a lot of effort over 100 years ago to build these buildings. They used a lot of energy to do it, and we get to benefit from that. These are existing historic buildings that we can benefit from all that energy and carbon that went into making it, so we don't have to recreate. The next goal we have is to really reduce the operational carbon, meaning reduce the energy load of these buildings. And we're doing that by achieving PHIUS passive house certification. So this is going to be a passive house project. And then finally, we're using low carbon and carbon storing materials. So this is our site. It's a great location. It's right in downtown Fitchburg, right on Main Street and Summers Street. There's an existing firehouse that's historic, existing commercial building, with ground floor retail and two floors above, and then this vacant lot, which we're going to fill in with housing. Here's the firehouse, the back of the firehouse, the vacant lot, which will be a 5-story building, and then the existing this existing historic building that will have ground floor retail and then housing above. Overall, we'll be creating 44 units of affordable low-income housing on this site. We're also leveraging federal historic tax credits. And that is the real trick, I think, of this project, that we're trying to do both achieve passive house while achieving the requirements by National Park Service. So as many of you know, National Park Service oversees the federal historic tax credit program. So we've really had to work with them hand in hand to meet these goals. And then, so I'm going to start, even though energy has probably even larger impact in the long term on a building like this and how much energy the building uses, I want to start by talking about the materials that we're using in construction, because that really informed the decisions we made on how we're going to achieve our energy savings. So what does it mean? What does embodied carbon mean? Well, embodied carbon is the impact of all the greenhouse gases that were attributed to the materials throughout their life cycle. So all the greenhouse gases that it took, say a piece of steel, a steel stud. So the energy it took and the greenhouse gases of extracting that metal from the ground, transporting it to a factory to turn it into steel, transporting it to another factory to turn it into steel studs, and then transporting it finally to our site. So it's all those steps have a huge amount of greenhouse gas as part of them. And so we're trying to figure out, how do you limit the greenhouse gases? So I wanted to, at our site, we're looking at all of our materials and trying to consider how to have the lowest carbon impact. But I'm going to use for an example of insulation. And the reason why I'm using insulation as my example to kind of explain this concept of what does it mean to be a low carbon material is because many of us have spent our careers, I know Lauren and others on this call, working really hard to insulate our buildings. And we were very, very proud of our work leading that movement. And then only to, lo and behold, find out that some of the insulation that we've been using actually has a huge global warming potential. The impact on climate change is actually really bad. And in the long term, unfortunately, the impact that insulating the energy you're going to save takes a really long time to offset all the carbon and all the greenhouse gases that were emitted to make that insulation. So we're all looking very seriously right now at the insulation that we're using. So on this graph, you can see XPS. And XPS is a very common insulation. And you can see that it's emitting a lot of greenhouse gases to create it. The same thing with foam, so closed cell foam. It starts to get a lot better with mineral wool, fiberglass bat, and these are using a lot less. So as we're doing our project, we banned XPS. We said we're not using XPS on our project, and I would recommend all of you doing the same. We are using mineral wool, we're using fiberglass bat, and we're using a little spray foam, but it has low HFO potential. Now, when we look at this, something interesting is happening. Why are these negative? Why is there negative embodied carbon in some of these materials like cellulose? Well, the reason why is that these materials are actually storing carbon. And this is where I think it gets pretty exciting. With some materials, it's actually better to, instead of, for example, cellulose, you're taking it out of the waste stream, you're actually storing the carbon that's in that paper. And rather than it decomposing and releasing carbon dioxide to the atmosphere. So if we're able to use materials over here, these materials will actually store carbon. And this is our goal of our project, is to try to use as many materials over here as possible. And then if we have to use some materials that emit carbon when they're created, we use materials that emit very little. You can also do this look at flooring is the same way. So you can see, like, for example, carpet. Actually, when you create carpet and then replace carpet over its life cycle, it emits a huge amount of carbon versus if you're able to, if we could all afford, which would be hard, if we could all afford, for example, FSC softwood flooring or hardwood flooring, it's really doing a great job of storing carbon. Marmoleum flooring, again, it's a product that stores carbon. Okay, so as we're thinking about materials, one of the easy ways to think about, well, which materials store carbon and which don't? Think of natural materials. Natural materials tend to store carbon. When I first became interested in green building, it was in the 90s when I was in high school, and there was a big natural building movement at that time. We were building, I was going out and volunteering to build straw bale houses. And that felt really good. These houses that used very little energy to operate, but they were also made of natural materials, straw and plaster, clay from a site, mud from a site. And that felt right. As the green building movement has got expanded since that time, we got really into huge industrial buildings that used a lot of unnatural materials. And a lot of them actually have a large climate change impact. So if we can get back to natural materials, that starts to get really exciting. And you can use natural materials even in large multifamily buildings, like for example, mass timber. You can build a high-rise building out of wood, which we're not doing here, but maybe we should have. And that ends up storing carbon. And the way we get our data is from environmental product declaration. Another thing to mention is concrete. Concrete contributes to 8% of global greenhouse gas emissions. That's huge. We've got to figure out how to reduce the climate change impact of concrete. And on this project, we were able to do that. So the first thing that we're doing on our project from a carbon standpoint for materials is use less materials. We're starting with existing buildings. And this is why if we're able to appropriately retrofit historic buildings, they're all right off the bat using less carbon. Other goals of our project to reduce carbon is on the concrete. We increase the fly ash of our spec and we reduce the Portland. What we did was we hired new frameworks. Jacob Rakusen, he was if you're interested in his work, he was a number of years ago, he was the NESI keynote speaker. Talked about low carbon materials, but we hired him to help us identify key areas where we could really reduce the carbon of our materials. So he worked with a structural engineer to change our concrete spec, to increase fly ash and reduce Portland, which really made a big difference from a climate change perspective. And then our structural engineer approved that, and that was included in our spec. On the insulation side, we're using cellulose insulation, which is recycled newspaper, mineral wool, eco fiberglass. We're using Glavel, which is a recycled glass product that goes underneath the slab instead of foam. And then in the one location, which was the ceiling of our parking garage, we couldn't get away from foam. So on that, we're using a low HFO foam. So the blowing agent is low HFO, and that has less of a climate change impact. For studs, our spec shows that to use wood studs instead of steel studs. Now, I say that was right before closing. That's what our spec said. With the price of wood that went up so high during our close, right as we closed this project in May, it looks like the project's using steel studs, which is really disappointing. But there's a reality of cost here. But in general, if it was a normal market, wood and steel were about the same, and it's much better to use wood studs than steel. And then on flooring, where we're using wood floors where we can, we're using marmoleum. And then Interface has a zero carbon LVT floor. And then finally on our sheetrock, we're using an eco-smart sheetrock, which has recycled content. So those are some of the approaches we're taking on the material side of our project. On the operational side, we've got to figure out how to reduce the energy loads of our building. And many of you, I think your last presentation or one of the ones recently was on Passive House. Passive House is an incredible way and a very clear path to reduce your consumption of buildings. So on this, we said we want to do Passive House. Now, because it's a historic tax credit project, it's really hard to do that, but we're able to achieve it. I'm going to share some of our tips of how we did that. We also, in addition to following PHIUS, we're also using solar. So we're installing a 100 kW system on our roof to get to very close to zero energy on this project. Okay, so passive house concepts. Many of you probably already done a passive house project, but if you haven't, I just want to talk about some of the big points of a passive house project. And for this project, we're going through the PHIUS certification program. There's also passive house PHI, but we decided to work with PHIUS on this. So the big takeaways are you need to have continuous insulation without thermal bridging, which is really hard on an existing building. So I'll talk a little bit about that. These buildings need to be very airtight, very low air leakage. You need high performance windows and doors, and you need heat and moisture recovery ventilation. And then finally, minimal space heating, space conditioning, air conditioning. So you're able to really reduce your energy load because the building's really well insulated and airtight and has great ventilation. Then you need very little space conditioning. I'm not talking today about our mechanical systems, but I just want to mention, because they're pretty standard for passive house projects, but what we are using are heat pumps and an ERV for ventilation. Okay, so where is the air barrier? In passive house, the first thing you do is you want to figure out where your air barrier is. So you have 6 sides of a box, but you prevent air leakage on all those 6 sides. So in our project, we have these 2 historic buildings on either side with a new building in between. We talked to PHIUS and we said, hey, how do you want us to approach this? Should it be 3 separate buildings? And what we decided in the end was that the whole project is modeled as one building from a passive house perspective, because we are sharing all of our mechanical systems. So we have one central mechanical, and it's serving all these. So our air barrier includes all the residential parts of this project. The retail space is excluded from passive house. And I'm going to talk a little bit about that at the end, but please, if you do a project, don't forget your retail space. I've forgotten it on other projects, and it hurts your overall performance of the building. Okay, so embarking on this, the first question was, can we do passive house and a federal historic tax credit project? We decided to do this and take the risk. And the reason why we felt like we could do it is, one is this building has simple architecture. It's not a really ornate building. It's really a box, this building, and then the firehouse. So we felt like we were, if it was a really complicated building, I think it would have been too hard to do as a federal historic tax credit, but because it was a box, we felt like we could do it. The other is that it has simple windows. They're just double hung windows, 1/1. And then finally, there's limited exposed brick on the inside of the building. So we're able to insulate the inside of the building, which is huge. If we weren't allowed to do that by National Park Service, we couldn't do this project. Okay, so National Park Service has, when they first reviewed this project for federal historic tax credits, I wasn't part of the team yet. So they applied for, more of a standard renovation. And so there were certain requirements put on the project by National Park Service that we had to accommodate to when we designed it to passive house standards. The first was windows. One of the biggest problems with achieving passive house is that casement, you really need casement windows, double hung windows or single hung windows really won't work. There's too much air leakage. So the really important thing of this project is we were getting these casement windows that look like double hung windows approved for the project. And I'm going to share some details on that. The next is wall section depth. National Park Service had restrictions on how much we could build up the interior wall, which made it harder for us to achieve our energy goals, but we were able to do it. National Park Service also in some locations were requiring exposed brick. And then there are thermal bridges that we just couldn't get around, like in some of the floors that we had to address in other ways. And then like most historic projects, you can't have anything visible from the exterior. So all of our mechanicals had to be on the roof and not too close to the edge that they would be seen from the street. And then finally, the new building. National Park Service had a requirement that the new building has a brick facade brick actually has a huge climate change impact. And I'm going to talk about that at the very end of the project. Okay, so windows. This is what our windows look like now. They're double hung windows. Because of the poor condition of the windows, we're able to replace them. And here they are on the interior. So what we ended up doing was, even a few years ago, we wouldn't have been able to do this project because there wasn't a product available on the market. Now there's this exciting product called a simulated double hung casement window. They look like a double hung window, but they perform like a casement. So the bottom sash actually comes in, and we're using triple pane simulated double hung windows on this project. This is a Zola window. We did not use Zola on this project. We're using Euro, but I like this photo because it kind of shows you the different ways these windows can open. So they can open a little like a tilt, or open in this direction. This is key to the project, that we're using these simulated double hung windows. To our knowledge, no simulated double hung windows have ever been approved on a federal historic tax credit project to date. So we worked very closely, starting about 2 years ago, with National Park Service to have them review our window options. We started by showing the existing conditions of the windows, showing what a few different manufacturers could do in terms of measurements, how close they could get to the existing conditions. We went through this whole process of getting feedback from National Park Service to really select the window that would work for this project. Here is the beautiful result. This is like a mock-up where we were just experimenting to see how it could work. The window itself, it will have child guards on it, so it really won't open this far. But here on your left is the original window, and on your right is the simulated double hung casement window. And this is a Euro window. It looks really good, but it didn't look good enough. So we did this mock-up, and we decided we needed to do better. I do want to mention that we did a lot of work with National Park Service. It's our understanding that if this project looks good, getting these kind of windows will be easier, and getting passive house projects approved that are federal historic tax credit projects, that National Park Service is taking a close look at our project, and this could be a really model project, so it's easier for all of you to do one of these projects in the future. Okay, so we installed our mock-up, and the first thing we noticed was they were really, really shiny windows. They looked like almost like office windows, really reflective. And that's a no-go with National Park Service. It doesn't look historic. So the solar heat gain coefficient was too high. And basically the solar heat gain coefficient is how much heat is reflected off the windows. And you want to have you want a lot of reflection, because then you have less air conditioning load. However, this was too much, it was too reflective. So we ended up changing that in our second mock-up window. Another issue was the window was just too bulky. It didn't look good. You can see over here, it was too thick. So we ended up installing it again, and it looked a lot better. The other issue was the meeting rail. The meeting rail was like the biggest issue here, because we're doing a triple pane window, and also because it's a simulated double hung window, there's a lot of hardware in that meeting rail. And the result was, in our first mock-up, was when you look down from the street and looked up, that meeting rail stuck out too far. It just looked a little bit odd, and it also created too much of a shadow. So in our next version of the mock-up, Euro was actually able to thin that meeting rail quite a bit, and that made a huge amount of difference. Okay, so that's on the window side, and that was our biggest stretch on this project. The other issue on the project was wall section depth. This is what the building looks like. This is the firehouse. This is one of the fire poles, which I think is really cool. National Park Service is requiring us in a few locations to keep the exposed brick. So that's a big energy penalty. Another requirement that they're doing for us is, this is the attic, is that they're requiring that we only build up the interior wall surface by 4 inches from the existing surface. So here's your brick. We have about 2¼ inches of plaster lath and strapping, which they're allowing us to remove. But then from there, we're only allowed to build up the wall surface another 4 inches with insulation. So that ends up being about 6¼ inches that we can build up the wall surface from the existing brick. So that's not very much to get to passive house, but we were able to figure out a method to do it. So the first thing, if going back to that low carbon and low embodied carbon materials, is we wanted to go foam free. And that's hard, because the easy way to do this would just be to use high density foam, and that would probably your air sealing and your insulation. But we said, no, we're going to try to do better. So if any of you have been in building science corporations presentations, they warn you that you can have really terrible freeze thaw issues within masonry walls if you get a lot of air leakage and moisture from the interior into that brick. And that can cause spalling over time. It can cause corrosion of studs and other things. So you really want to reduce how much air leakage and vapor can get into that brick from the interior, so that that brick is able to dry out. So we have to be really careful. This is not something we can play around with. So like I said, the easy way to do this would be closed out spray foam. The other great thing we could have done if we had more space would be to have our studs have a nice mineral wool insulation layer, and then have service cavities so that we could protect our vapor barrier, so that when people make holes in the walls or do other things, that they don't damage that vapor barrier. However, because we were limited by National Park Service of how thick that wall could be, we couldn't have a service cavity. So the wall section that we settled on, and this, by the way, I need to say that this could change, because over the course of the year, once they get into construction on the walls this winter, they might come up with a different strategy. But the strategy that building science like best looks like this. So you have your existing brick, you have air barrier that's painted on, you have mineral wool, and then you have a vapor barrier membrane on top of the mineral wool, and then you have your studs with your cellulose in it, and then you have your drywall. And the reason why building science like this was because that vapor barrier was protected, that people would be less apt to somehow, if you put the vapor barrier on the interior side of that cellulose, someone might make a hole in it, and then that vapor and that risk to the brick wall would be huge. But this is a pretty complicated thing to build. So it will be interesting to see once we really get into this construction what this looks like. The other thing I mentioned that we're doing is under the slab. Many of us who are doing passive house projects in the past have used foam insulation under our slab, which it works really well, but the climate change potential is still high because it's foam. So what we're using is this product called Glavel, which is made of recycled glass, and it acts like gravel, which is, I think, really cool. So you don't need gravel, but it's insulated. It has an insulation value. And there's a new factory that's being created in the Vermont area. So this will be a relatively local product. And then finally, on the operation side, I just want to call out the building storefront. So a lot of times in the passive house program, we're only getting the housing portion of the project certified through passive house, and we're not certifying the ground floor storefront. We are, though, very much focused on making sure that storefront is as energy efficient as possible, because first, it's the right thing to do, because you don't want your tenants to have huge energy bills, and from a climate change perspective, it's the right thing to do. But second, if you don't deal with your storefront and your ground floor, it's going to cause a big energy penalty to the units above. So in here, one of the issues is we're required to keep this this kind of Art Deco glass facade and this aluminum single pane retail facade. So what we're doing is we're actually building an interior glazing wall that will create our air barrier and thermal barrier, but on the outside of the building, it will still look the same. And then finally, we've dramatically reduced our energy load. So then we're installing solar. This is the building next to the roof of the building next to this project. So it's pretty exciting. It's a great site for solar already. We're installing solar on the new building and the 3-story building, but we're not installing it on the firehouse because there wasn't a lot of roof area. There were shading issues, but there was also concern from a historic perspective that you'd see it from the street. So we're trying to do, it's really, really important for a project like this that we're meeting the historic requirements, both from a tax credit perspective, but also because it is the right thing to do. We want this property to be a beautiful asset in Fitchburg that really celebrates the historic nature of the community. And so we're trying to do the best job we can to achieve both our climate change goals and our historic goals, while providing 44 units of really high quality, low-income housing to this community. So this is really a bear of a slide. So maybe just listen to me instead of looking at it. But I just want to go through the things that we did well, and then the things that we really had to compromise. In terms of material reduction, we did a great job. We're using a historic building. We're reusing these buildings. So right from the get-go, we're having less of a climate change impact. On the energy side, we're using passive house, solar PV. On the concrete side, we've reduced Portland and increased fly ash, which makes a really dramatic difference in terms of greenhouse gas emissions. Now, on the siding of the new building, and I alluded to this before, but we really didn't want to use brick on the new building because it has a large climate change impact. But National Park Service required us to do so. So I'm going to talk a little bit about that right before I complete the presentation. On the insulation side, we did a really good job. Cellulose, we're using eco fiberglass within the demising walls for sound, and then mineral wool and glad wool. But we did have to compromise. We're using low HFO foam in the parking garage, and then but we are using no XPS. And then on the wood instead of steel studs, we were hoping. And then the flooring I mentioned, and the countertops. We wanted to use FSC wood. It didn't work for this project financially. Okay, so before I conclude, I just want to talk a little bit about brick, because I bet many of you are specifying brick buildings because they're less maintenance over time and they look great. Brick uses creates a lot of greenhouse gases to create it. And you can see here, for example, this is brick over insulated metal panels or metal studs. So the greenhouse gas emissions is actually quite a lot. Even thin brick, if it's combined with precast concrete, has a big global warming potential. Ideally, if you can on your project, consider using thin bricks, and especially if you can do them on, thin bricks has a much less global warming potential than regular brick. So it's really something to consider. Additionally, on this project, this is kind of a little bit further down the road in construction, but we were not able to use thin brick just because of timing with our drawings. However, we are exploring this product called Green Leaf, which is a brick made of recycled content. And a number of universities are using this. And I suggest if you're using brick, this is a product that you can look at. And then the last thing I wanted to mention is team coordination. We are doing passive house, and our contractor and other members of the team that really got that. It's like, okay, we have to be passive house certified. We have no choice. They have no choice. They can't cut corners there. However, on the low carbon materials side, we do not do a low carbon materials certification program. And partially because we didn't have any funding to do that. And also because those programs were just in their infancy when we started this project a few years ago. I wish, and I would on future projects, if I'm trying to use low carbon materials, I try to do some kind of certification program. And just because it makes some members of the team, it's easier for them to kind of glom onto a checklist and to know that there's a certification that they have to meet. And as a result, they're not as apt to just say, yeah, we're going to get rid of all the wood studs and go to steel. like that. Like it's easier on the value engineering side to keep certain team members in kind of in line and to be focused. And I think that just has to do with personalities and how different people think, but that would have really helped on this project. So with that, I wanted to, we can open it up to questions.
Great, thanks so much, Heather. Fantastic presentation, really, really exciting project. So we've gotten some good questions coming in as you've been presenting. So I'm going to start with some of the questions that came in the beginning around embodied carbon and certain types of materials, specifically as it relates to the materials you had identified as sort of plant-based sequestering type materials. A general question about durability and longevity of those types of materials, and how that gets factored into how you think about the life cycle sort of carbon impacts of these materials.
Yeah, that's a great question. So how long those materials last is really important to think about. So materials that are undercover, like insulation, cellulose, flooring, some of your finished materials, your studs, I think the durability isn't really an issue. When it comes though to siding, that's where this starts to get a little bit stickier. So for example, wood siding, if you remember that chart, looks a lot better than say brick. However, over the course of the life of the wood, you have to paint it a lot. And that has a climate change impact. It also is hard for many of us in trying to deal with our budgets in low income housing. You know that it's really hard to have, painting on your reserves coming up for the next, 20 years and doing it at different intervals. So that's something we have to think about. We looked into some different types of paint. We also looked into some different types of stain. We also looked into, like, for example, like cedar and other materials that you don't touch that wouldn't be painted. And so all of that is, we're trying to think about all of that as we're factoring this in. And in the in some of the analysis, how the life cycle and the length, how long those materials last and how durable they are is incorporated into some of those calculations about carbon.
Great. And a question about whether you guys looked at carbon as it relates to your roofing material. Like, did you do any sort of evaluation of TPO versus rubber roofing, anything like that?
We did not on this project. So we're using a reflective roof, but that is not an area that, what we did was we had new frameworks look at like the top, what they believed were the top 10 biggest climate change impacts of our buildings. And that's kind of where we focused our time, and roofing did not come up as one of those top 10.
So related to that, folks looking for guidance about what you think is the right time and sort of level of investigation for these types of analyses in terms of your project schedule, your design phase, as well as the things you're focusing on. So it sounds like really highlighting and focusing in on strategic decisions around these really significant investments of embodied carbon is a good approach. But when in the project design timeline would you recommend folks start to really think about that?
As soon as you can, just like with Passive House, you can do it halfway through, which we did. We had all our funding in place, so we were at that level of drawings. But then it was like I guess we were into our process quite a bit before we decided to go Passive House and low carbon. So I would do it sooner if you can. But those lists that I gave you of like the big things that we focused on are big things that all of you can focus on in any of your projects. Those are pretty typical for what your biggest impacts are on a project.
And do you have a sort of preferred embodied carbon certification program or pathway that if you were to move on to your next project and be doing this again to try and have that sort of certification to keep everybody on track? Have you been looking at any particular programs?
Yeah, so Jacob from New Frameworks, who is our carbon consultant, he has recommendations. I feel like I can't off the top of my head share those, but we could do a follow-up email and I could find out from Jacob what he's recommending.
Great. Transitioning to more of the sort of net zero energy question, did you guys look at how much solar you would have actually needed on the project to get it to a net zero project?
Yeah, we did, and it wasn't actually that much more. We definitely would have needed more roof area. So I can't remember off the top of my head how close we were, but we were actually pretty close. And we do have all our systems the whole thing is net meter, so it's all central, so we're able to use all that solar for the property pretty easily.
Great. And then some more sort of technical questions about the presentation. So there was a question about the insulation detail at the beam pocket, where you've got the wood structural member entering into your masonry structural wall. Can you talk a little bit about that pocket and, you know, what sort of considerations were given in terms of durability and insulation of that area?
So it sounds like someone's been at Building Sciences, CODA's presentations before, because that beam pocket area is a huge risk area because it's a thermal bridge and there's a big condensation risk there. So we had CODA from Building Science to really create a nice detail there. So we're air sealing it. We are using, by the way, we are using spray foam for air, like really small areas where we needed to do some air sealing if we weren't able to do caulking. So we're doing some nice air sealing. We're also doing insulation details to make that safe. For the building durability, because that's our biggest, I mean, really our biggest concern is even if we do a great job on passive house and then 20 years later we have, like, you know, a building that's rotting out, that's not really going to help climate change in any way, or will help our residents. So that was really important that we detail it.
And then some follow-up questions about some of the materials you talked about, just sort of ease of getting your concrete spec, right? Do we see transition in the marketplace in terms of being able to specify these different mixes in a more affordable and accessible way?
Yeah, so we didn't get pushback on the concrete spec, and I was really surprised. Our structural engineer didn't have an issue with it. And so on that, I don't have an update on it, but it seemed like that was not going to be a major problem, that it was proposed, and then we were able to include it in the spec with his blessing. So that was pretty exciting to me, because that's a huge difference on the impact. One of the things when you're talking to your engineers is in LEED, you know, you can get points and things for adding fly ash, but a lot of people forget to reduce the Portland. The whole purpose of adding the fly ash is to reduce the Portland. The Portland has the biggest global warming potential. So you've got to reduce the Portland along with adding fly ash. And that's like something a lot of people forget. And so please remember that when you talk to your structural engineer about this.
And then last but not least, some final questions to close out about your windows, because your windows are amazing. And that is a big piece of being able to get the certification and meet the historic requirements. So a few questions about whether or not you're able to have screens on your windows. Oh, did we lose Heather? Heather, I think we see you now. Yeah.
Okay. Yep. Yeah. So you were asking about the windows?
Yeah. So screens, are you going to be installing screens on those windows?
Yeah. So the screen is going to be on the inside of the window. So this is a little bit of a compromise because it's National Park Service doesn't want to see the screens on the outside of the windows. So it's going to be kind of like this screen that lifts up on the inside, and then you have to open, or actually, no, I'm sorry. There's a little, there's going to be like a little hand thing that you can put your hand through to open and close that window. So it's a little awkward, but it's something that we were able to solve.
And then some clarifying questions about the solar heat gain coefficient. So I think someone was a little bit confused about sort of whether we're talking about higher or lower solar heat gain coefficient, but essentially the windows were too reflective and you needed to reduce the reflectivity so it actually increased the amount of heat gain into the building. So you had to adjust your WUFI model based on that.
That's right. So what the result is that we have to, because we couldn't have as reflective a window, we have to use more air conditioning. So our cooling load had to go up because we couldn't have that reflection because it just didn't look right from a historic perspective. So there's an energy penalty there, but we were still within reason, and we were still within reason for comfort, and we're still able to get passive house despite the fact that we had to change that.
Great. And then I think the last question was just about, the sort of window process. And it sounds like having a sort of thinner window generally would have been better from the National Park Service perspective. And so, are you seeing other manufacturers sort of responding to this request. Obviously, if you're doing a triple pane high performance window, there's only so thin you can make it. But are you seeing other manufacturers trying to get even thinner windows that have the same types of performance?
Yeah, so we're working with Yarrow. They really bent over backwards to meet these requirements. And I think other manufacturers are really starting to step up too. So Zolo is another one. There was a number of manufacturers since we started looking that have come out with different products. But the big thing is talk about simulated double hung. So you got to share with your manufacturers your existing conditions, really tight drawing, and see how close they can get. And I would not try to do this on a really complicated window. We lucked out. We're not, it's not even a 2/2 window. It's a 1/1. And if you got more complicated, I think it's going to get a lot harder. But on a window like this, it's probably the easiest one that you can do. And I want to mention too, we had to use triple pane. We probably in our climate could have gone down to double pane, except for the fact that we had some energy penalties because we couldn't make our walls that well insulated. And we, in some places we had to do exposed brick. So if in the future MPS was more comfortable with making the walls a little thicker, maybe we could have gone down to a single pane window. I mean, not a single pane, sorry, a double pane window, and it could have even got thinner. So those are some of the compromises.
That's great. And I think there's more interest in understanding exactly how that interior screen works on this type of window. So maybe we can follow up with folks with more links to websites that kind of show sort of the detail that you guys have implemented.
Yeah, you might need to wait until we're under construction on that, because that was one of those things where we had different ideas, but we're kind of pushing that a little bit further in the process. So
great. Well, I think our timing is just about perfect here, but I did want to spend a minute just transitioning from the work that you've done in Moran Square as a part of your work with Biome to the new role that you have at Rocky Mountain Institute and some interesting things that you've been working on at the federal level in terms of resources for doing just this type of work, really decarbonizing our existing building stock.
Yeah, so I manage the Realize program for the East Coast. Realize is our deep energy retrofit accelerator program. So if you're interested in doing a deep energy retrofit, we're going to be providing assistance in Massachusetts and other states on the East Coast. And I'm happy to share some of that individually with any of you. But on the federal level, I'm also working on federal policy to support tax credits for deep energy retrofits as well as passive house projects. And we are trying to build a coalition of people in affordable housing to support these efforts. So one of the things that you should be aware of is on the federal level right now, even though there's lots of people talking about low carbon, like we're doing a lot on climate change, we're helping buildings, there's not really good incentives for housing. The maximum incentive that's being considered right now is a tax credit of $5,000 per housing unit. And that's for DOE zero energy homes. We believe there should be a performance tier that's passive house that should have a higher incentive. And if you want to do a comparison, electric cars are getting $12,500 tax credits, but housing, which is worth so much more than a vehicle, is only getting $5,000 a unit. Housing unit. And that's a real shame. And I think that's because we in the housing community haven't advocated enough, and we need to. The other thing that we're trying to do is we're trying to create support for a basis adjuster for the low-income housing tax credit program, that just like if you're trying to develop in a difficult area, you get that 30% basis boost. We're trying to do the exact same thing for deep energy retrofits in the 4% tax credit program. So if you would like to get behind any of these, if you're going to meet with your senators, Congress people, love to talk to you. We had a letter of support that was circulated to about 100 congressional staffers about a week ago that we're getting some interest. We also have a blog that we wrote last week that talks about these, but we've got to do a better job advocating for ourselves if we're going to really figure out how to decarbonize buildings in the US. We need to, or we're all going to be left behind, especially low-income people. So let me know if you want to get involved in that stuff, because I find it incredibly exciting. I just think there's so much we should be doing in that area.
Definitely exciting time around that. Great. Emily, do you have other announcements you want to make before we all disperse for the day?
I think that's it. I guess the one thing is that if folks know about the New Gravity Conference, the Passive House Conference, it's happening virtually next Wednesday and Thursday, the 21st and 22nd. It is at night. It's a 7 to 9 p.m. on Zoom, but we'll send out the link for that. And then we're starting a Slack channel, the Energy Cohort. So we want to make sure that folks get involved in that. So we'll be sending that link out and would love to have people's engagement with that and feedback as well. So I think that's it. Thank you so much, Heather. This was amazing. And thank you all for joining us today. And we'll share the presentation and slides and the other resources that we referenced after this session. So thank you all, and stay safe and healthy and cool there.
Thanks. Bye-bye, everyone.
Bye, everybody.